Okay, hi everyone. This is Kerim Baran with SolarAcademy. Today I have with me Patrick McCabe of GreenLancer. GreenLancer has been in the solar industry almost as long as I have, for almost about a decade. And Patrick has been a co-founder of GreenLancer throughout this whole time. So Patrick, can you please tell us a little bit about your company, what you guys do, and we'll go from there. Thanks.
Sure thing. Yeah, thanks, Kerim. Yeah, GreenLancer, founded in 2013. We support the boots on the roof, the real heroes of the solar industry, and we help them by providing them access to qualified design and engineer partners. And we do this through our web-based platform that connects the installers with fulfillment partners that specialize not only in design and drafting, but also engineering. And over the last 8 years, we have supported over 3,000 solar installers who have used our service to install over 100,000 different projects, both residential, commercial, and even utility type projects all across the US.
Great. That's great.
Yeah, thanks.
So I think you had a presentation ready to dive into. So
absolutely,
launch that.
Yeah, I'll go ahead and do that. The presentation itself is going to be an overview of permitting for solar projects, and we've had the pleasure of working in almost 13,000 different jurisdictions across the U.S.
Wow.
And so and we'll kind of get into this a little bit. So awesome. Let me go ahead and share.
Great. Perfect.
All right, are we seeing solar permitting guide? Perfect. All right, so the first thing I want to say is that there are over 18,000 individual building departments and over 2,000 different electric utilities across the US. Each one of these different jurisdictions or these building departments is located within a county, a city, or maybe even a township. And each one adopts their own requirements, their own codes, and their own rules that govern solar. The building department is usually staffed by people who work there at the building department. And their job is really to make sure that not only is the solar being installed safely, but also that it fits the local requirements. So some areas may be historical. They want the historical significance of jobs and projects to follow along that. Other places may have zoning that prevents solar from where it can go. And so we'll see that on the individual basis, each one of these jurisdictions essentially owns the codes and the regulations that happens, which means that if you are a nationwide solar provider, it's very difficult to understand what the potential requirements may be at any particular local level because each one is different. And for the most part, all of these different building departments have a pretty well documented application process that will be used to prevent unsafe designs and grid interconnections from being proposed but installed at the project level. And most of the time, what they're actually reviewing in these applications is to make sure that the contractor is licensed and insured, and in some cases bonded, but really so that the proposed solar design fits within those regulations and doesn't break any of the codes that have been set aside. And so we'll take a look at some of these codes right now. The codes that govern solar vary from state by state, and usually a state will set what types of codes they'll adopt and then allow each individual building department to select which codes they actually want to enforce. Most of the codes start with the International Building Code, and at the bottom here, I have kind of identified what parts of the International Building Code or of each one of these different code books actually pertains to solar. But the IBC is a well-known code. It's followed not only in the US, but also all across the world. And each jurisdiction adopts previous versions or vintages of the code book. So for right now, we're in 2021. The local jurisdiction may now just be rolling around and adopting the 2017 code book or the 2015 code book. So usually they're adopting codes 5 or 6 years after they've been authored. And these code books are continuously being updated. They're living documents. So there's further clarifications around new technology, or if something they've seen an issue, like for instance, fires, they may try to address those by including more codes to follow. The International Fire Code and really all of these codes are trying to prevent any fires from erupting from these electrical, or if it's a structural, making sure that the roof will not only be able to handle the downward pressure of the arrays, but also the up force due to wind and loading. And the National Electric Code is really our Bible for the most part for solar electricity. We actually have our own chapter, chapter 690, that completely deals with how solar is installed and the codes that govern it.
Right.
So as I mentioned, usually the way that this whole process starts with the building department is by creating a design drawing. And these drawings, are pretty much known to everybody as blueprints, but these drawings will have different pieces of the design documented so it can be reviewed by a code professional. Almost all of these start with a cover page, which will not only kind of propose or outline the proposed project scope of work, but also the codes that regulate that and any special notes that need to be taken into account by the actual plan reviewer. The next one is a site plan, and that site plan will typically show from a very high level not only the property boundaries, but any offsets of where the solar is going to be located from those property outlines. The site plan will also include a basic overview of where the equipment is going to be installed. And when we zoom into the project level drawing, you'll actually be able to see that in more detail. And sometimes you'll actually be able to see where the mounts or the attachments to the roof will actually show up. And that's the structural piece of the design. We have an electrical piece and we have a structural piece. The structural piece is going to cover how it's mechanically attached to the roof, but also give some real basic calculations like pounds loading per attachment, etc. So we'll have details showing how the actual rail is going to be attached to the roof. And the roofs could be different, right? For a residential project, you have clay roofs, you've got composite. Each type of roof is going to have to show detail of how that attachment actually is going to be fixed to the roof. From there, we go into our electrical design. The most noted electrical schematic is the single line diagram. And this is from a very high level showing the equipment and orientation of how it's going to be configured at the system level. So usually you'll have panels on the left-hand side. And as you move in from the DC into the AC going through the inverter, it's going to show any safety disconnects or any other type of equipment that's going to be added to the system, including how it interconnects to the actual grid. Solar is governed by, as I mentioned, Chapter 690 of the NEC, which requires all systems to be labeled with safety placards or safety stickers. So these safety stickers not only need to show, hey, danger, there's PV, DC flowing through this, but also we'll have to show how many volts or amps are at the point of interconnection, so that in case any utility personnel or fire personnel are there on site to handle an emergency, they can see that solar is not only connected to the system, but also that it could potentially be very dangerous if electrified. And then the last piece of the designs will include data sheets and any other pictures that will help the plan reviewer. But the real point of the blueprints is to give the plan reviewer a piece of information and basically a documentation showing how the system is going to be configured. And so at any point in the future, they can always go back to that design and see how it was actually created. The last thing here is that a lot of jurisdictions may or may not require a professional engineer or a registered architect to stamp the drawings. When we say stamp the drawings, that means that they're going to review the design and make sure that there's any issues could potentially be prevented from actually happening. And so when they give their wet seal to the actual plan set, it means that those projects have been reviewed by a professional engineer and they are code compliant. And so the professional engineer will actually assume the liability for those projects in case anything happens. And so I mentioned, here's the different sheets that are in a blueprint set. title sheets, electrical sheets, safety sheets, site plan, project plan, civil sheets, and the PE stamps if required. Now, when you're at the actual building department, there's a couple different types of plan checks that that the building department may have. The most common of which is a plan drop-off. It happens to be the slowest way to get approval or permission to actually install. And that's where you drop off the plans and the application and you wait for the approval status. Most of the time, a review process will go to different departments within the building department. So they may have a structural department, they may have a zoning department, a planning department, electrical department, etc. The plans will actually travel from department to department, and they'll receive the stamp of approval. And if there's any issues, there'll actually be corrections or comments that are be given back to you and say, please address this. The fastest way of actually getting plans reviewed is over the counter. So over the counter basically means you show up with your application and your plans all printed out, and you sit there at the counter while the plan reviewer actually goes through them in person with you. It's the fastest way. A lot of places have it, especially where solar is popular. And usually it just takes you needing to make an appointment or schedule something in advance to be able to get the fastest review done. There's another type of application process which is happening to becoming more and more prevalent, and that's the electronic submission. The electronic submission is somewhere between the plan drop-off and over the counter. Basically, you will submit your plans electronically instead of at a counter, and you still have to wait a lot of time for the approval status. So it may be a day, 2 days, or a week even before you'll get that approval or, again, comments back. So out of all of these, electronic submission is definitely the easiest because you don't have to roll a truck there to actually do anything. But the fastest way is over the counter. And I would say the default is the plan drop-off. That's where you'll see as most of the jurisdictions are still doing the drop-offs. The permitting process is not only involving the local jurisdiction building department, but also includes the local utility. And so on this flow chart here, we have two different sides. We have the building department on the left-hand side, and we have the local utility on the right-hand side. The local utility will not allow you to operate the actual solar system until you've got the inspection passed from the building department. So after you get a plan review, you'll have an inspection that happens after the project's installed. And so before they can actually turn on the power from the solar system, they have to get acceptance from the permission from the utility to get PTO, or permission to operate. So there is a little bit of an overlap of the processes, and basically you cannot turn that thing on until both the utility and the local jurisdiction building department have agreed that it passes. And so it could be sometimes days, even weeks before all of the proper checks have been successfully gained, and it could be a process. You know, to get to installation may take a week or two, depending on the local jurisdiction, and then it may even take another week or two to get inspection, and another week or two to get permission to operate. So we'll see that vary quite a bit depending on if you're located in California or maybe like somewhere maybe in the Midwest where it could take a lot longer. So that's the basic overview of the permitting process. And I have a couple tips to take with you so that if you are permitting a solar project in a new jurisdiction, or maybe it's your first project, things that you can do to help you. And that's the first thing is always call ahead. Local websites, especially building departments, they don't get a lot of love or attention. And so a lot of times they can be out of date. The best way to get accurate information about the design constraints as well as the actual application process is to call them. And the things that you're going to want to confirm is that your address of your project is actually located in their jurisdiction. I've heard lots and lots of installers go to a local building department only to find out that it's the county building department, not the local city that they thought it was. So confirm the jurisdiction, confirm any special requirements for solar. And if you're in California or anywhere where there might be fires, check with the local jurisdiction to see if there's any fire code offsets. These offsets will be basically pathways that you need to give around the edges of the roof. So in case there is a fire, personnel can get up on the roof and be able to put holes in that roof. If you are calling ahead, this will give you an opportunity to learn the process, the application requirements, the fee structures, and the lead times. The biggest thing your customers want to know is when their project is going to be installed and when they can flip the switch. That's going to heavily depend on that local jurisdiction and that local utility's lead times for approving the interconnection application and approving the permit. The pre-submission review is something you can always ask the local jurisdiction for. This is basically where you'll take your blueprints in a little bit early before you actually do the formal submission, and you have them take a quick look at it. They can, at that point, give you any feedback before you actually go through the formal process, which may take days or, again, weeks before you actually get issued comments or corrections back. So to go in and actually have them take a quick look before you submit can save a lot of time down the line. Finally, some other types of tips: organization, appearance, and basically preparing yourself to defend your plan set. The organization coming in with a binder with all the right information, with the correct drawings, the amount of copies, the right paper size, it goes a long ways. Not only that, but so does your appearance. Looking business professional, being in a good mood, approachable. These will all help you get through this process much faster. And then being ready to defend. When a plan checker asks you a question, so is this really what you're intending on doing here? Be prepared to be assertive. And not only that, but if the code checker finds that's wrong, if you have a red or black pen with you, you can make changes very quickly using black ink and actually make those revisions on the fly. This has saved my butt a bunch of times when working on a larger project where the lead times, again, can be a week or 2 weeks before you get that opportunity to submit again. And finally, the last thing I would say is this: the best time to do the plan submissions are early in the day or right after lunch. This gives you the most lead time to be able to address people, and also it's usually before they get really busy at the plan office. And if I had to say anything else, it would be to build relationships with the plan checkers and inspectors. You can do this by being professional, conciliatory, but also by showing interest in creating relationships that will really help down the line when you're doing a lot of projects in that local jurisdiction. And that is our little toolkit on how to permit solar projects.
Great. Thank you very much, Patrick. This was very, very helpful. A couple of questions. You guys have been probably the leading company in the US market doing this type of providing this type of service to contractors all across the country, probably all 50 states at this point. What can you tell about, the challenges of standardizing permitting? What is your vision on that? How was your role in that? Can you talk a little bit about that? And then maybe after that, if you can tell a few words about your other lines of services and business as well.
Sure.
That'd be really useful.
Yeah. So solar, as I mentioned, it's 18,000 jurisdictions and 18,000 different requirements. And so that makes it very difficult to scale, especially if you're a regional powerhouse or trying to take a national approach to installation. And that's actually been one of the limiting factors from preventing those organizations from scaling, I feel. So there are several different initiatives in works right now. One is an initiative to create a national permitting standard where basically all jurisdictions adopt the same codes and requirements like they've done in Australia, like they've done in Germany. That's had a huge effect on the ease to be able to get these projects permitted. The second initiative that GreenLancer is personally working on is the initiative called Solar App. And this is a automated electronic submission, plan review that basically takes in key design configurations and characteristics, and will give you basically an approval or non-approval. And for anything that's non-approval, that'll go the standard way of going through a plan check review. But for the ones that do qualify, basically an instant permit. And that'll go a long ways. And I think it's being adopted in several jurisdictions right now as we speak and being piloted across the nation. So there'll be a lot more to see from that. And in terms of GreenLancer's kind of business capabilities, not only do we do the design and engineering and professional engineering, but we also offer plan expediting, which is basically a person taking the plans that have been generated and running them to the actual building department in person. So for anybody who's really busy, doesn't have the time, is not geolocated where they can actually be able to do that very easily, this gives them the ability to get the permits into the plan offices that don't have electronic submission yet.
Great, very, very useful. Thank you for that.
Mm-hmm.
And you also do provide some services for the telco industry, if I remember correctly.
Yep, GreenLancer's got a sister division, or a sister, I should say, organization called G-Force. G-Force is taking the same exact business model we have in the solar side and is doing it for telecommunications. And we've got roughly about 5,000 sites under our belt, and that's been alive for about 18 months. So we're taking the same sort of kind of concept of standardizing services, making it available to the telecom and infrastructure, I guess, contractor base out there. And we've been seeing a lot of success for it. So there is the design, engineering, and permitting is a huge bottleneck, not just for solar, but for a lot of other industries as well.
And what are some of the other things you're working on for the next year or so?
So this year we got 2 initiatives. We're adding a EV charging division, which will be really exciting, considering all the momentum it's building there. And then the other side is we're mostly known as a virtual engineering company, but this year we're going to be moving more towards a virtual EPC. So not only offering the engineering component of a project, but also the procurement as well as the construction piece. So being able to get installers, on-demand electricians, these are the types of things that we know a lot of installers need help with, and these are the types of solutions we want to offer through our web platform.
Great, great. Thank you very much.
Thank you.
This was very helpful. Thank you.
Great. Yep.
We'll do more of these hopefully in the near future. Thanks.
Sounds
Patrick.
good. All right. Bye-bye, Kerim.
Yep.